Okay, let's talk about solving multi-step equations. So this is when it starts to get kind of crazy and guessing and checking isn't much of an option anymore. You really need to understand your inverse or opposite operations. Your verbs, add, subtract, multiply, divide. Okay, so the rules or steps I guess I follow is the first thing I always think is I think of my order of operations. I deal with the parentheses. So, I mean, this is not really a negative x because I've got a 4 out front that needs to be distributed. So I need to deal with parentheses first. So I'm going to do that. Remember, I've got my left side and right side. Okay, so the first thing I say to myself is simplify both sides of the equation. So on the left side, I can distribute 4 through this difference to get rid of the parentheses. So 4 times 1 is 4, and 4 times negative x is negative 4x. And then I have plus 3x equals, and then I'm going to distribute, I like to use red for my steps. I'm going to distribute negative 2 to x and 1. I'm going to distribute this sum, and I get negative 2x minus 2. Remember, when you multiply or distribute a negative number, it always changes the signs inside the parentheses. Okay, so first x was positive, now it's negative. The constant term 1 was positive, now it's negative. Okay, so I can actually go a little further here. I said I'm simplifying right now. I'm not using algebra, I'm simplifying. So I see that I have two like terms on the same side. So let's go ahead and combine my like terms on the left side of my equal sign. 4 is just the constant term, it's going to stay by itself. Negative 4x plus 3x. So I have 4 negatives, 3 positive, I have 1 more negative. So this becomes negative x. Negative 1x is just negative x. On the right side, these are not like terms. Variable term, constant term. So I'm just going to write it out. There's no math I can do right now. Okay, I have simplified the left side. I can go no further. I simplified the right side. I cannot do anything else. I'm ready for my algebra. So remember that you're looking to get all your like terms together. So the two variable terms need to go together, and I have 1 on both sides. And the two constant terms go together, and I have 1 on both sides. So I'm always thinking ahead when I'm solving it, what would be the fastest way to my answer? In this situation, because I'm going to have to move one of the variable terms, and I will have to move one of the constant terms, there's not necessarily a faster way to do this. My preference, some people like to always put the variables on the left. My preference is I like to get x positive because I don't like to deal with negatives. To do that, I always start by looking at my variables, and I'm like, all right, here I've got, this is my smaller of the two variables, negative 1, negative 2. Negative 2 is smaller. So I'm going to move this one, and I'm going to move it to the other side by using the addition property of equality. Now, when I add it to the right, this is going to give me 0. I've got to keep these balanced, so I add it to the left, and I'm going to add it to its like term, because those need to be combined. So I have negative 1x, positive 2x, and that gives me a total of 1x, or 4 plus x. Remember, over here I got 0, alright, that was the inverse property of addition, and I have left with negative 2 because of the identity property. I don't need to write this 0. Okay, so I've got my variable term x is on the left, and it's all by itself. There's no other variable terms that I need to put with it. So I'm going to leave x exactly where it is. I'm thinking I'm going to move the 4, because listen, if I move the negative 2 over here, then everything's on the left. I want x on one side, constant terms on the other. So I need to move this 4. And I'm going to do that by the opposite of adding that 4 is going to be subtracting that. And this is my constant term, my like term, so I'm going to subtract it from negative 2. Alright, 4 minus 4 is 0. Your identity property says that I don't need to write that 0. This is just going to be x. Positive x, I don't need the sign anymore. I have both negative numbers here, so the combination is 6, and they're all negative. Alright, so I found a solution, and I want to make sure that it's correct. So I'm going to go over here and check. Now again, I can do this by hand, but here's my original problem. 4 times the difference of 1 and a number plus 3x, 3 times that number, equals negative 2 times the sum of a number and 1. Okay, so what I want to do, I'm not sure if you can see that or not, so I didn't get my calculator. I'm going to use my store key to put my solution that I got, negative 6, into my calculator. So, negative 6, store into x. Alright, now my calculator knows what x is, and I'm going to check to see if the left side of my equation, so 4 times the difference of 1 and a number, plus 3 times the number. So that's the left side. I'm going to hit enter. No, I'm not. Yes, I am. Okay, I get 10. So on the left, I have 10 equals, and now I'm going to need to put in the right side. Negative 2x plus 1. Oops. Negative 2 times the sum of a number and 1. And if I'm correct, this will give me 10 as well. Yes, it does. So because the solution that I got is negative 6, when I substitute into the left, I get 10, and when I substitute in the right, I get 10. The two sides were equivalent. So my equation was true, and check. Okay, so I want to do one more example with you. So up here I said that the first step I always do is simplifying. Simplify the left, simplify the right. And if I have parentheses, I want to get rid of those as soon as possible. So my first step is usually distributive property. I'm going to show you an example of where I might do it just a little bit differently. So I've got 1/3 times this sum here. Now the problem is, if I distribute, if I multiply 1/3 times 7, I'm going to get 7/3. That's messy. When I multiply it by 5, I get 5/3. That's messy. I don't want to be dealing with fractions. So what I would probably do here is, because this because this 1/3 is multiplied by the whole left side, see, I'm going to distribute it. Well, that's when you look at your left and right of this equation. If I multiply it once I distribute, I'm multiplying 1/3 by the whole side. So instead of distributing, what I'm going to do is I'm going to use my inverse operation, my inverse property right now, where if I multiply by the reciprocal, 3/1, if I multiply by the fraction by 3/1, essentially that is times the whole left side, because that would get distributed. So I'm just going to do that. I'm not going to distribute it because I already did. By multiplying by 1/3, I am doing the whole left side. Now when I come over to the right side, I have to be careful because I'm going to multiply this whole side by 3/1. Now 3/1 is just 3. So what I've done here is I've gotten rid of my fraction. Yay! So let's go ahead and multiply this out. Again, the reason why, in other examples I dealt with this more at the end, but if I have a fraction times a whole parentheses and it's not going to be pretty when I distribute, I would consider multiplying both sides by the reciprocal and see if that would get rid of the fractions. Okay, so on the left side, I'm just left with 7x plus 5, so I do not need the parentheses anymore. On the right side, again, remember, this is a little tricky. I have to do it to the whole side. That means what I'm going to do is distribute. So 3 times 3x is 9x, and 3 times negative 5 is negative 15. And now this is something I'm much more comfortable working with. I've gotten rid of my fractions, my parentheses are gone, so I'm down to my last couple steps. Again, I have variables on both sides, and I have constant terms on both sides. I want to get the variables alone. So let's get them together first. I like to do the x's first because I'm always thinking, how can I make a positive? If I move the smaller one, I can make a positive. So in this situation, I'm going to move the 7x. So I'm going to do that by subtracting it. That's going to give me 0 over here. I'm going to subtract it from 9x, the like term, the variable term. So on the left side, adding 0, the identity property says that just leaves me with 5. On the right side, 9x minus 7x is 2x, and then I've got minus 15. Okay, I'm getting close here. I have one variable term, which is what I want. It's on the right side. So the smartest thing to do next, the quickest fix here is going to be get the 15, the negative 15 out of the way. So I want x alone. If I move the x back over here, I'm not getting it alone. Alright, I want to get these constant terms together. If I move this one over here, again, x will not be alone. Everything will be here. So to get x alone, I got to get this negative 15 out of the way. I'm going to use my inverse property here. When I add the opposite, I get 0. My identity property says I don't need to write that anymore, so I'm just going to have 2x on this side. Remember, I got to keep my scale balanced, so I got to come over here and add 15. So that gives me 20. Alright, now I'm one step away. This is 2 times x. So the opposite of multiplication is division. The division property of equality says do it to both sides. Divide by 2 here, I get x equals 20 divided by 2 is 10. Again, your symmetric property says, it doesn't matter if I switch sides here on an equation. A little different with an inequality, but in an equation, I can just switch the sides there. So my answer is x equals 10. Alright, so I'm going to go to my calculator now and have it help me check my original equation. Let's write that out. I had a 1/3 7x plus 5 equals 3x minus 5. I'm just writing in black there what the original equation was. Okay, I want to make sure that I don't make any silly human errors while I'm checking. That's the whole point of checking, so I'm actually going to do it with my calculator. So, x is my variable. The solution I got was 10, so I'm going to store 10. So remember, I store by using the store key right down here. Okay, store 10, store into x. So now my variable x is 10. I'm going to enter the left side of the equation. 1/3 parentheses 7x plus 5. Alright, so on the left side of my equation I got 25. And I'm hoping that the right side will give me the same thing. So 3x minus 5 gives me 25. So the left and right side of my equation were equivalent, which means that the solution that I came up with over here, 10, is the correct solution.